Hey guys, I'm going to be doing a little bit of maintenance over here on the Milltronics CNC mill today. What I want to do is go ahead and extract all of the old or original coolant that I put into the machine when we first fired it up. My intention is to have the trim Microsol 685 coolant in all of the machines here. So I'm going to be slowly going around to each one and cleaning the sumps out, sucking all the old coolant out, and we're going to be making new coolant to install the machine. I've got my new coolant mixing system finally operational, up and running. There's been several different components that I've had to gather to get this system built and then plumb it in to the wall there. So it's a really nice system, and I'll show that to you, where I can literally go over to the hose reel, grab the hose, pull it over to whatever machine I want, and then turn the ball valve on, and it mixes the water and the coolant together right into the machine. It's a really simple process, so I'm going to share that with you too. So we're going to go ahead and get busy getting the coolant out of there. We're going to be using our Sump Shark, and this will be the first time that we're going to be using the Sump Shark. I was waiting for this opportunity to be able to clean these sumps out, and that's what we're going to do. So I've got the coarse, it's like a burlap sack, so a real coarse filter in there just to catch any chips that have gone down through the screen into the sump. And what I'm going to be doing is just storing it in the tank here for now. I still need to go pick up a couple of the plastic barrels. There's a company here in town that sells those, and I have some barrels here that I can pump the old coolant or oil into, which will be picked up by a company like Safety Clean or one of those guys around here. I can have them come by and pick up the old fluid. So I've already got the ML16 full of fresh coolant. We just did that. That was the first time that I put coolant down in the machine, and we got it primed up, and it's working real good. So let me show you the coolant system that we've got made up here. Like I said, this really came together well and works nicely. The only thing that I still got to do that I keep forgetting is I need to get like a little ball valve for the end of the hose right here. But for now, this is going to work just fine. So we have this Hydra Blend mixing unit that's mounted on the wall now. That should be the model number 6160. All right. And then this is the coolant that we're running. This is from Master Fluids, the trim Microsol 685. This is what Justin over at Master Fluids recommended for me to run. It's a really good coolant that whenever the coolant dries on the machine after you use it, the oil there in the coolant actually covers the machine and does a really good job of keeping everything oiled and protected and keep it from rusting. All right, so we've got our hose reel mounted up there, and they installed a proper rated hose there that would work well with oil. All right, and then we've got it plumbed in. What we did is we plumbed it right in to the tap water system there underneath the sink using copper, made it look really nice. And then this right here is your backflow preventer. So this is installed per county code right here, and this will prevent any water coming back from the system into the city water system. So this should work really good right there. But literally all you do is come up here and turn this ball valve on here, and it's just going to let the tap water pressure go through here. It's going to siphon the coolant, and it mixes it and then discharges it out of your hose. All right. And then I've got a refractometer that we're using to test it. And what we're shooting for is right at a 10% mixture in the machine. But I'll go ahead and turn this on to show you. When you first turn it on, it's a little squeaky sounding, and usually you can just turn it off and then turn it back on, and it kind of gets away from that. So let's see here. See what I mean? It's like it's got to get moving and get some oil in there, and then it kind of goes away. So you can see it siphoning the oil straight from the bucket there. And I've got it going into this bucket here. You can see it mixing up some coolant now. All right. We'll go ahead and shut that off. This is adjustable, by the way. You've got this gauge here on the side from 0 to 10. And generally, this is kind of a gauge to get you real close, but you use the refractometer to test your coolant. So what I was doing was I was mixing up just a little bit right here and then testing it. And once I had the mixture right, I went with it. So it should be good right where it's at to go ahead and fill up the CNC lathe too. So that's it. It's really handy. This is a 50-foot hose, so I can pull this hose out to any of these machines right here. The only one that it will not reach is going to be the Hydmec saw, but that's not a problem. That's the only machine that we'll just have to we'll just pump it into a bucket and then pour that coolant into the machine there whenever we're ready to do that. So that's it. I think I showed every bit of that there that I wanted to share with you. So I'm going to come over here to the mill now and see if we can get that old coolant sucked out of there. By the way, this is the digital refractometer right here. You just put a couple of drops there on the sight glass, close it up, hit go, and then it gives you what your it measures it and tells you where you're at, and you can adjust it over on the pump according to where you want it at. So let's see if we can get this old coolant out of here now. That's about as far as I can get the sump to come out because the pump is behind it. So that's, they got it where you can just pull it out like this, and then you can slide the screen back. Or you can just take it off. We'll take it off and clean it out. That was pretty incredible how much or how quickly it sucked out all that coolant in a matter of about a minute and a half. So we still have some down in there. So I'm gonna keep working this to try to suck all this out that we can, try to wipe it out a little bit before we fill it up with some fresh coolant. I know it's a little dark here, but I've got my toe jack on the back of the sump here. All I'm gonna do is just pick it up a couple of inches or so, just to tilt it forward so that all the rest of the coolant will just roll to the front side so we can finish sucking it out. Let's try that right there. I gotta say that worked really well, and really surprised how fast it'll suck that whole tank down. So I would say a minute it had the whole tank. I was messing around at the beginning seeing how it would do, pulling the tramp oil off the top, you know, skimming it, and it did just fine. It's going to be a real nice machine to have to clean out all these machine sumps whenever it comes time. And then you can use it to filter the coolant as well. You have the finer screens in here as well, or filters that you could put in there, so you can actually suck all your coolant out of the sump to filter it, get all the particulates out of it, and then pump it right back in. So all you do is just you swap this out over here to the discharge, turn it back on, open the ball valve, and pump it right into another container if you want to, or right back into your sump there. All right, we got our sump cleaned out pretty good. I've got her wiped out the best I can, and it's time to fill it back up with our fresh new coolant. All right, we got our hose pulled over there to the mill. Simply turn the ball valve on. And that pail is almost empty, so I'll have to watch this and replace it here in just a couple minutes. So our sump is full. I'm going to go ahead and take this dropper and get a sample of it. So I checked this about halfway through. I was a little bit low on the mixture there, so I adjusted the pump to get more oil to see if we can. We're looking for an 8 on our refractometer. All right, here's our refractometer. So we're going to put a drop here on the little sight like that. Close it up and then hit go. 9.2, so it's a little bit high on the mixture there, but I think that's going to be fine where it's at. I don't think that's going to hurt anything. We're looking for an 8 on the refractometer, and that's going to equivalent to about 10% mixture, which is what you want for this particular coolant. I don't know if that's going to be the same across the board for other coolant, so I'm only talking about the 685 right now. But that should be good. The important thing is that you have enough soluble oil in there to prevent any kind of rusting on the machines or your tools, vices, and also to give proper lubrication to the cutting tools when they're working there as well. Too little soluble oil in there, and then you're going to have rusting issues and that kind of stuff. So I think a little bit heavier is going to be okay, but you don't want to go too heavy because then you're just kind of wasting it and using up more than you should. But I'm going to leave it right there. The alternative there is that we could pump a little bit of that out, you know, with the Sump Shark there, pump a little bit of that out and reduce the mixture and fill it back up again. I just don't see the need for doing that, so we're just going to run it right where it's at. So this should be good to go. We'll get it back up underneath there, and the Milltronics should be ready to machine. All right, so this just happened to happen after I got through with the Milltronics. I came over here to the hide mech. I needed to use the saw, and it was low on coolant. So I filled it up, or I topped it off with some coolant. I need to clean this whole thing out, but I just needed to add a little bit of coolant there to use it. And I walked away for about 5 minutes, and the coolant was all over the floor right here. So pulled the Sump Shark over here to use that to vac all this coolant up. And then I just kind of mopped it up with the pig mats there. There's a little bit left under the saw, so that's why we got the pig mat there. But that is it's another great use of having one of these types of machines around here, is for coolant spills like this, machine coolant spills, which is what happened for me. What I have figured out has happened is down inside here. So this is your chip pan right here. It slides out. There is a thin layer of like oil and stuff built up. I'm sorry, the screen is back there. The screen was clogged up with chips and oil and, you know, tramp oil and dust and all that kind of stuff. And so what it did was it overflowed this right here, and I didn't see that. And when it does, it starts overflowing on the inside, drains down, and then it just goes everywhere. So one of those little particulars about this machine that I figured out. So I got to get this guy pulled out of here and clean that that swarf bin out really good. So anyway, this literally just happened. I just got it cleaned up. I thought I would show you guys this too. Now we can get back to our sawing. I've got some 1 1/4 4140 here that I'm cutting up to make some small shafts out of. So this is going to end up being not only a job for someone, part that I'm machining for someone. This is also going to open up another training exercise for me for my CNC machines. I'm going to start over here on the manual lathe to get these guys faced off here. I've got a stop set up in the chuck where I can just put these up in there and face in the link. Even though these are the sample shafts right here, these are what we're making. There's a couple of dimensions that are different between the two. Why that is, I don't know. It's just however they were machined from the factory. One of them is 99 millimeters long, and the other one is 100 millimeters long, but the shoulder lengths are slightly different there as well. Like I said, I don't know why, because these appear to be identical, but they're not. So anyway, we're just going to go ahead and get our shaft stock faced off here and get them to length. And then we're going to move over to our Milltronics ML16 to get that programmed on machining the shafts here. So what we have done is we have an off-the-shelf part right here. These gears, so you've got one that's a helical gear, and then you have one that's a straight tooth gear right here, like a spur gear. Okay, so we're going to be making a spur gear copy, and then 2 of them there with the helical gears. Okay, so as I said, off-the-shelf parts, so you can machine these shafts and then install these however you would like to. We're probably going to make a slightly interference fit on these gears, and then with a key, and end up dimpling the 2 spots for the set screws to help lock them on there as well. Okay, but simple off-the-shelf parts that you can get without having to machine these gears. What I was told is that these go to a CNC router, or actually they have several CNC routers that they're using to route foam boards. but they cannot get these parts from the manufacturer anymore. So they were looking for someone that could help them machine a couple of these shafts to get this machine back in operation. But what they would like to do is, if this works out good, everything works right, they would like to order just a small quantity of each one so that they can have spares on the shelf, because they said that they have had problems with these gears getting wore out or the shafts getting wore out from abrasion. So anyway, that's what we're going to work on. We'll go ahead and get them faced, but we're going to follow up with another video for some CNC training, and we'll see if I can figure out how to get these guys machined accurately and quickly over on the CNC lathe. I'll just get one end of all the shafts faced, and then we'll bring them back in there to face them to our exact finish length. So I have the tip of our tool and the face of the stop right here set to exactly 100 millimeters. I did a sample piece and just got it set. So all I have to do, now that we got the ends faced on one side there, stick it in there to the chuck stop, tighten it up, and I'm going to move my carriage over to 0 on the digital readout here. And this will take care of the 100 millimeter length. So we'll show you what we got. It just moved, but anyway, so we'll set our Z to 0 for the 100 mil, and then when we go in for the 99 mil, we'll just go -1 millimeter exactly and face those other two off there as well. All right, let's pull this out and see how close to 100 millimeters we are. All right, this is the one we just faced. I'd say we're pretty darn close. Look at that. All right, good to go. So let's do 2 more at 99 millimeter. We're faced in, going in. Bring our carriage in exactly -1. So we're at our -1 there. Let's face these and see if we can get them to 99. All right, that's a little too heavy. I don't want to cut that all at once. I think that's going to be a little heavy, but all right, let's just see what it does. I didn't really tighten that very tight, so let's give it a snug again. Okay, it'll handle it. I'm gonna give it a quick check, but I'll show you guys. We're gonna be good right there. So let's go ahead and Grab the other one and get it faced off as well. Let's see how we did. I went to 100mm again. I need to. I know what it is. I backed off the carriage, and then when I went in, I went back into 100 instead of negative. Instead of 0, I was supposed to go to -1. So that was my bad right there. Let's redo this. All right, now I'm just moving it back in. That thing loves to beep at you. There we go, okay. And it's gonna string a chip. Now we should be at 99. There we go, 99. Okay, that worked out well. All right, so we've got our blanks now faced off, and I just wanted to go ahead and tackle this in the manual lathe using my chuck stop to easily get these guys to the exact length, because I didn't want to have to go over to the CNC lathe and have to worry about the face length. I've got to get some a chuck stop set up for that chuck there as well, but I already had one set up for the manual lathe, so it was just an easier op, especially with the DRO to get that done. So I'm gonna what we're gonna have is a follow-up video, because like I said, this is gonna be a training video for me on seeing if I can get this guy programmed and get these sizes. My goal is to try to hit these sizes within tenths. Okay, you have a bearing journal here and you have a bearing journal here. Now in the center, they said this is where the pulley goes, so there's a belt that I believe drives this guy. So I would like to try to hit these sizes for our bearings on a proper size, so that they have the proper interference fit without having to do any kind of hand filing or polishing to get them there. So that's my goal. And then we'll also, as I said, we'll make it so that we sweat these gears on the end so that they're on there nice and tight, and then dimple it for the set screws there. Okay, so I will come back with a separate video on our journey into hopefully getting some of these shafts successfully machined over on our Milltronics CNC machines. I recently got this crate of tooling in here. This is some used stuff that's going to be going to the American Pacemaker, and I wanted to share it with you because there's a lot of really good tooling in here that's going to save me a lot of money, because one of these items I was prepared to buy pretty soon so that I would have one, and I'll show you what I'm talking about. But I was able to purchase this from Mark Coxon up at Machine Tool Emporium. He's in Louisville, Kentucky, and has he's gained a pretty large audience across social media. He is a machine tool broker, so he buys and sells used machine tools, and a really nice guy. And I think I got really lucky finding this, and I was able to make a deal with him. It's some lathe tooling that I believe he had forgotten that he had. He had it like stored away, and they recently moved into a brand new building. So I think he's been like getting everything cleaned out, moved into the new building, and he found this stuff, some lathe tooling that he didn't want anymore. So he put it up for sale, and I was able to message him right away, and he gave me a really good deal on this stuff, and I'll show you what I mean. So it's going to be some really good tooling for the pacemaker. Let's go ahead and share it with you. We have got some really nice size bell centers, a 4-jaw chuck, which is like a live center here, and these large boring bars. So the main thing that I was already wanting to acquire some larger bell centers for the American Pacemaker. So I'll show you what I'm talking about. We'll pull this guy out. You can see just how big this one is here. And the taper is the proper size for my pacemaker. It's a 5 Morse taper. I'm gonna go ahead and set this on the table here because it is heavy. Those are solid ends there, but it's in great shape. It's got a nice smooth feel to it. I didn't have any of these guys for the Pacemaker, so when I saw this post, just the bell centers alone was more than worth what he offered to sell me the entire lot. He did not want to piece it out. He said, I'm only going to sell the entire lot, so that was fine. So look at this guy. It's another 5 Morse taper. Look at that guy. So perfect for pipe and tubing work. Really come in handy. Here's another one. It's a little bit smaller, so this is the same one as this guy right there, just a smaller size and diameter. All we got to do is just clean up the Morse taper, probably hit it with our flat stones to get rid of any nicks and burrs on it. I'm not going to pick that guy up because that one is heavy. All right, there is a couple of live centers in there as well, the smaller ones there. And then of course the 4-jaw chuck. Now these guys are number 6 Morse taper. This one and this one. Too big in the Pacemaker. You can probably buy a socket extension that'll go from number 5 to number 6, but not necessarily what you want to do. What we may do later in the future is see about, I don't know if maybe we can take this guy out and modify it for a number 5 Morse taper and be able to use this in the tailstock as well. It doesn't get used a lot, but sometimes you have a job where it's the perfect tool to get the job done. All right, so we've also got these boring bars there as well, and this was something else that I was wanting to tool up for the lathe. So like this was an added bonus because I've been wanting some of these guys as well. So we'll pull this one out of here and I'll show it to you. So this one is a 2.5-inch diameter boring bar. It uses the, I believe that's either the 5 or the 600 series. I believe it's a 5 series CNMG insert there. That's going to be a sweet one to have. And then there's a couple more as well. So this one is also 2.5-inch. Hard to do this with one hand here. So we got 2 of those guys. My holders for the multi-fix system, it will take 2.5-inch bars. So this is a perfect size boring bar to go with my tool post and my system over there, my multi-fix from Pee Wee Tools. We have a couple smaller ones there that'll be handy as well. We got this guy. All right. I believe this is the 1 3/4 inch. And then this one here, I believe, is 1.5 inches. So I plan on keeping all the boring bars. Let's just go ahead and pull that last one out. All right. So we got that guy as well. So awesome lot of tooling for our Pacemaker. So the Aloris tool holders, I don't need, but as I said, this was a complete lot. You had to buy everything. I've already made a deal with Aaron Jenkins. He is wanting these holders. This is the style. He's got a DA Aloris tool post for his big lathe. So these are gonna go to him. He's up in Alaska, and I told him that I would save them for him. So once I get all these out, I'm gonna get them cleaned up and we'll package them up and send them up there to Aaron. There's a couple more in there. This is another DA Aloris holder right here for a 2-inch bar. So Aaron's going to get that stuff there. So just really nice to be able to get a good load of heavy duty tooling like this for our big lathe for the American Pacemaker. I mean, just these bell centers right here and one of these boring bars by itself, I would have made that deal with Mark on this stuff. But so excited to have that. And just wanted to share it with you so I can get it all cleaned up and put away. And now we got us some more really good lathe tooling for our American Pacemaker. Here's a couple machining projects that's coming down the pipeline very soon. I'm actually getting ready to get started on the V-block project coming up next. But this one's going to be coming up soon. This is going to be a really good project for the Flex CNC here. This is going to be the adapter plate that I need to make for our Tombstone City T-slot table. Now, in case you guys missed it, this is a brand new T-slot table that was given to me by Tombstone City. My understanding is that this was a new item that they had on their shelf that I don't know if they couldn't sell it or they didn't have any need for it or whatever, but they offered to give it to me because they had no need for it anymore and they wanted to clear up the shelf space. So I thought that it might work pretty good over here on the Flex CNC, since we got such a big machine here with bed space. All right, this was made to fit a certain CNC machine. I can't remember which one that is. So we need to be able to adapt it. Now you could sit it down on here and use some toe clamps if you wanted to, but I don't want to do that. I wanted to actually machine an adapter plate, which is going to be this guy here, so that it can just be mounted to it all the time, and we can pretty much just leave it mounted on the machine, but if you don't need it, we can pick it up and move it and set it down somewhere else if we want. So we'll get to this project pretty soon. It should be some pretty good machining. We'll probably mill the frame on the outside, mill the top, get our holes in there, and then mill the bottom side there as well so that it's parallel, and get our T-slot table bolted down to it. All right, so I want to get my pair of big V-blocks here ready to go at any time on the Flex as well. So I wanted to be able to do the same thing. That's what these two steel plates, well, I got another one, but here's the steel plate. We're going to fully machine this guy. So it's going to be machined with keys, so that will be keyed down to our bed rails here, and the V-block is going to be keyed on top of it as well, and it'll be bolted to this all the time, and we can just take these guys and set it down on the Flex. It'll be perfectly lined up, ready to go, and then we'll have some nice big V-blocks to set some larger round pieces or some of the larger shaft work that I want to get to. And that's one of my goals. I want to get a nice gearbox shaft in here, get it machined, and get it in the Flex so that we can do some big keyway milling over here. So really excited to get to that, but we're going to get started machining these guys real soon. This is going to be some more of my Milltronics CNC training with our TRM 3016 mill.